Alright, welcome back today on how to do the friction lab. Alright, at this point your data table should look like this. You've got the weights that you put up on top of the blocks here. You've also got over on this column over here, you've got the mass of the blocks listed over here. And then this is the weights that it took after tapping to make the block move. So that's what we've got. Then we come back and we redid the lab with 500 grams, and this time it took 200 grams to make it move, and this was without tapping, which should make sense. It should be a lot harder to make it move without tapping the block. Anyway, let's get into how to finish this data table, and we can get this data table like wrapped up right now. So first thing we'll do though is I'm going to go get a brand new clean sheet of white paper out. So get me a new sheet of paper. At the top of this page, I'm going to write sample calculations, or could just wrote calculations, but anyway, it's too late. I've already committed. Calculations. And, oops, before I forget, I will probably go ahead and put my name and date in the top right-hand corner of this page. So anyways, I got my sample calculations over here. All right, the first thing I'm going to do is this. I'm going to go back, and the lens just fell out of my glasses. Okay, better now. Alright, so the first thing on the data table it asks for me to try and find, it says find the weight of the block and the masses. So here's how I'm going to do this. How do you find weight? Well, geez, I wish we had an equation for weight. W equals, oh, good grief. What would be a great equation? Oh, yeah, W equals mg. So there's how we can get our weight. W equals mg. So for my very first one, weight would be, let's see, 0.2. My mass would be the two masses combined. So for me, it's going to be 0.322. So I'm going to have 0.322 times 9.8, and that's going to give me my first weight. So 0.322 times 9.8, and so my first weight is 3 and I'm trying to think how many decimal places I want to keep on all these. I'm going to go ahead and keep 2 decimal places, but I got a feeling I'm not going to be able to use them. But anyway, I'm going to go ahead and round that to 3.16 newtons, the correct unit for weight, of course, being a newton. But anyway, so now I've got my weight. So this is going to be 3.16. And now I can kind of get in turbo mode a little bit, because all I'm going to do for the rest of these is the same thing. I'm going to add my masses and times by 9.8. So my next one will be 0.422 times 9.8. And this is where the video is going to get kind of boring, because it's going to be me sitting here calculating all these numbers, but I'll try and be quick. 0.522 is 9.8. And I've got 5.12. Oh, come on, this is terrible. Oh, wait, I will cheat. 6. Bam, a little bit quicker. 6.09. Oh yeah, what an exciting video. Can't we make this even more entertaining? Maybe if there was fire, an explosion in the background. 7.07, and then the last one, this isn't that bad, 8.05. So now I've calculated my weight for every single trial. And now look at the next column over. We calculated weight, and the next column says normal force. Wait a minute, what is weight the same as? Weight is the same as normal force, which means if my weight is 3.16, the normal force is also, you guessed it, 3.16, 4.14, 5.12, 6.02, 7.07, and 8.05. Well, geez, my data table is almost completely filled out now. All I've got left is this one thing. Well, let's do that. That's going to be a very easy calculation to make too. So we're about to have this data table completely finished. That's not the hard part of this lab. The calculations are really the easy part. So there's my first calculation, W equals mg. My second calculation is for the force needed to move the block. Force needed to move the block. Well, the thing is, that force we need to move the block, that's how much this weighed, which means it's weight again. How can we always find the weight? This force is going to be equal to mg. all we're going to do is mg again on this. So I'm going to take a look. My first one was 50 grams. Now I do need to make sure and do something. When I do this calculation, 50 grams has got to be in kilograms. So 50 grams is going to be how many kilograms? 0.5? No. 1,000 grams in a kilogram. So this should be 0.050 times 9.8. So there's going to be my first one. So for me, 0.050 times 9.8, and that's going to be 0.49. So that's how I get this number, 0.49. And now I can just go down this list. The next one would be 060 times 9.8, 060 times 9.8, and be 0.5. I'm going to do 2 decimal places and everything, 0.59. That's amazing. The next one would be 0.075 times 9.8. I hate watching a video of someone punching numbers. 74. Let's see. 0.090 times 9.8. Oh, I'm tearing it up. I'm almost done too. 0.89. Oh, excuse me. 0.88. Getting close. Now I've got the 100. So 0.1 times 9.8. Why did I put that in the calculator? So that would be 0.98. And then 0.115 times 9.8 equals, get the next answer, 1.13. So at this point, my data table is almost finished. So I've got all this data done. Now all I've got to do is finish this little table over on the right side, and it won't be too hard. So let's take a look at something. It wants to know the weight placed on block. Once again, how do we find weight? W equals mg. So there's my mass. So mass times 9.8. Well, this is easy. What's half of 9.8? No answers. Bad class. Anyway, 4.9. So we've got 4.9. There's half. And wait a minute. The next column says normal force. Oh no. What is normal force the same as? Weight. So if the weight is 4.9, then what's the normal force? Thank you, 4.9. Oh, you're a great audience. I take back what I said earlier. All right. How did I find this little force before? What did I do? I did mg. But if that's 200 grams, I'm not going to go 200 times 9.8. What am I going to do? I'm going to go 0.2 times 9.8. And so I've got 1.96. 1.96. Now, I'm going to do one more thing. It says find the coefficient of static friction. So basically what it's saying is find mu. Geez, how can I find mu? Geez, I wish I had an equation for friction. I wish there was an equation I could just go and write like, I wish I could write an equation for friction like F equals, man, I wish there's some, oh, wait a second, mu N. And now take a look. The F is 1.96, the N is 4.9. I've got, so this is going to be my F, that's going to be my N, and now I can find mu. So F divided by N, that's my mu. So for me, it'd be 1.96 over 4.9. Let's see what we got here. It's basically 2/5. 1.96 divided by 4.9. Thank you for playing the game. 2/5. Ha ha ha. And that's, all right. So I've got a mu of 0.4. What's the unit for this? There is no unit. That's right. It's mu does not have a unit after it. Make sure on your data table, though, that all the other answers you've got do have a unit. And so this is what's neat about this lab. I'm actually done with my sample calculation page. It is finished. That is over. This page, 0.40. This page is actually now completely finished. So I'm actually looking like I'm done with this lab. So, Mr. Cole, why is this lab so hard? You got to do something that, as a 10th grader, you've probably never done before. That's make a real deal graph. Now, you're going to do this a bunch for me over the next couple of years. Now, the first thing we're going to do, you're going to get a sheet of paper, graph paper, looks like this. hopefully your graph paper will be dark enough that you can see the lines on the graph paper. If not, find the person making those copies and slap them repetitively. They probably deserve it. Now, here's what I like to do on the graph paper. Take a look at it. You can see that there's some bold lines and then there's some smaller lines, unless somebody made a terrible copy of the graph paper. But anyway, what I'm going to do is this. I'm going to go up from the bottom. I'm going to go up from the bottom, 1, 2, 3, 4, to the fifth little bitty line. The fifth little line, which is actually this first bold line across the paper. I'm going to take a ruler. I'm going to lay on top of it. As a matter of fact, to really make it stand out on this video, normally I would just take like this Sharpie pen that I've got here. Wow, I think my ruler is actually crooked. That's quite a buzzkill. But anyway, I would take this pencil on that first line, and I would make this sucker bold as all get out. Oh, I want everybody in the world to see this line across my graph. Doesn't hardly stick out, does it? I got an answer for that. Now, you shouldn't do this, but I'm going to for the sake of the video. I'm going to go back, and I'm going to grab a well, you can tell where I'm from now. I'm going to grab this Expo marker, and I'm going to really make sure there ain't no doubts. Wow, that looks horrible. But anyway, all right. Now I'm going to come back up here, and now, just like I came up to that first bold line from the bottom, I'm going to go over from the left side of the graph and make one bold line over from the left. So I'm going to line this up top and bottom. By the way, hopefully it goes without saying, everything on the graph needs a ruler. Bam. Oh yeah, this is fantastic. Oh my goodness, look at that graph. Oh, such a beautiful little graph. Now, I'm going to do something else. Before I forget, I'm going to go up to the top right-hand corner. I'm going to put my name and I'm going to put my date so that I don't forget. You know, it's very important to always put name and date up here. I'm also going to title this graph. Maybe I shall now call this the Friction Lab. Could you have called it something else? Well, yes, but, you know, I'm not trying to be creative here. So, Friction Lab. Now, I'm going to put something underneath this. Under that, watch this. I'm going to put, it's going to be a VS. And somebody might be going, can we write on the graph paper? Yes, you can write on the graph paper itself. You don't have to just write off in the margins of it. I really think margin sounds a lot like the word margarine. But anyway, that's neither here nor there. Anyway, so I'm going to put the verses here. What is this going to be a graph of? What am I going to graph? Well, that's a good question. I need to sit here and think about. We are going to graph force in newtons versus normal force. Normal force should be a lowercase n. I almost screwed that up. Just ignore that random mark. Normal force in newtons. Now, you do not have to write near as big as me. Matter of fact, please don't. Just use like normal size handwriting. Again, this is a video. Which means, here's what I'm going to do. This side of my graph paper is going to be force, and I'm going to do that in newtons. This bottom part of my graph paper is going to be normal force, and it's also going to be in newtons. So at this point, your graph should look like this. You should have normal force in newtons on the bottom. You should have force in newtons on the left. You should have the title up at the top, anything you want. But you should have this, force versus normal force in newtons, name, date. Okay, so far this graph is easy enough. Now comes the harder part of the graph, especially for like the 10th grade type student. Okay, but I think you're doing great, and I've got a lot of faith of you. And it's only took me 14 minutes sitting here saying this. Geez, are you still awake out there? Anyway, all right. So now what I'm going to do is kind of figure out the scale on my graph. All right. Across the bottom, my numbers look like 3, 4, 5, 6, 7, 8. So here's what I'm going to do across the bottom. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do this across the bottom. I'm going to make every one of these bold lines across the bottom count for 1. So that's going to be 1. The next bold line, I'm trying to put a nice little bold mark there. And that's going to be 2. And this is going to be 3. Oh, I love this game. 4. All right, you catching on? 5, 6, 7, 8. Could we keep going? You're dang right. I'm going to keep going. 9, 10, 11. Sorry for the pause. I actually do know what comes after 10. 11, 12, and if you've done everything right, you will get to number 13 all the way off the edge of the paper over here. All right. Now, unfortunately, the upside is not going to be easy as 1, 2, 3, 4, 5. By the way, hopefully you can figure out what each little line is now. If that's 1 and that's 2, that makes that 1.2, 1.4, 1.6, 1.8. Hopefully you can break this down at this point. Now, going up, my biggest number, and this is where I actually need, there are people in this room right now with me, and they're being respectfully silent, and I appreciate them highly. But I do need to ask them a question off their graph before I do what I'm about to do. I need to ask them, does anybody have a number greater than 115 right here? I need to know this. I need to know the biggest number in this room right here. Yes, I know it's on a very little screen at the front of the room. Stephen? 130. 130. Anybody bigger than 130? What y'all got? 145. How much? 145. So 145 is the biggest, so that's going to help me out. So 0.145. I need to know what's the biggest when I'm do this. So 1.42, because what I'm going to try and do is this. I'm going to see if on the graph if I can go by 0.1, 0.2 and still get everybody in. So 0.1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, yes. Y'all just got so lucky. I tell you what, it's fantastic to be a 10th grader. Because I'm going to make each one going up worth 0.1. So this would be 0.1. The next bold line will be 0.2, 0.3. Don't you love a video of someone counting to 10? 0.4, 0.5. If anybody else wants to help, they can. 0.6, 0.7. I'm going crazy, and it's all on video. 9. All right, so what happens when you get to 0.9? What's the next number going to be? 0.11. Who said that? 1.0. So 1.0. And then the next one's going to be 1.1. And then 1.2, 1.3, 1.4, which should get in even the biggest groups. 1.5, 1.6. Now, in theory, a college teacher might get on to you for this. 1.8. And then I get to 1.9 at the very, very top of the page. Because a lot of times a college teacher wants you to use every bit of the graph paper on your numbers. Well, you're not in college. You're still 10th grader, so we'll give you a little leniency here. Because what happens is like 1.1 is going to be my biggest number. Well, 1.1 is only going up about halfway on my graph, a little over. And so a college teacher might want you to make it where 1.1 is up here. But instead of having nice even numbers, 1, 2, 3, 4, 5, you'd have to go up like 0.8s or something every single time. And it makes the math a huge pain in the butt on the graph. All right, so here's what we're going to do. Are you ready for this? Are you ready? Dang, 18 minutes in. This is a horrible video. Man, I feel sorry for 10th graders now. Here's what I want to do. My first two numbers, this is what I'm going to graph. I'm going to go up 0.49. So I'm going to go up 0.49, and I'm going to go over 3.16. Now, I'm going to have to kind of do a little guessing here as to where these numbers are a little bit, but 0.49 up. Where is 0.49 up going to be? Well, here's 0.5 up, so where would 0.49 be? It would be just before 0.5, right? And then I said over 3.16. So I'm going to have to, and this is what gets hard, that's 3.2. So I'm going to try and find where these lines meet. So 0.49 and 3.2 meet right here And at that spot, I'm going to put a little divot, little dot. Now, so you can see why I'm doing better on another sheet of paper. In other words, I'm going to put a little spot that looks like this. And I'm going to do this for every one of them. And I should end up, this is what I should end up with on my paper. A bunch of little dots running up across my graph paper. This is what I want to see. A bunch of, will they make a perfect straight line? I do not know. My next one's going to be 5, 9, and 4, 1, 4. So my next one is here. And I'm going to keep working all the way up this graph paper. 7, 4. This is getting exciting. So here's my graph. I've got a bunch of dots now at the exact right positions. If anybody has questions about how to do this, you better ask. Anyway, and now for the big part. This is horrible. This is a long video. I'm now going to take a ruler. I'm going to lay that ruler down. This is big. This is where 10th graders, this is huge for y'all. This lab's going to take y'all forever because this is your first graph you've ever made before. I'm going to take this ruler and I'm going to lay it down. Where some of y'all get confused is this. Some of y'all someday will do a graph and you're going to have a bunch of dots and the dots are going to go bink, 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 bink. And you're going to be like, these dots barely make a straight line at all. Yeah, I know that. So what you do is when you get ready to do your graph, you don't actually have to lay your ruler so that it touches a single line. What you do is lay the ruler down. Now, if you've got one, let's say you had one dot that was like way down here, then you just X over that dot and ignore it if you got one that's nowhere near. What you do, though, is lay that ruler down so that it goes through the center of all the dots. It ain't even got to touch one. Lay it down so it goes through the center of all those dots. Now, this is big. Then you take your pencil and you make one mark all the way across the graph. Did I hit a single one of these dots? Nope, not a dang one. But that's okay. I want this line, and I want it to be nice, clean, and crisp. Now, I'm going to do the same thing on my graph paper. This is my graph. You can see my dots running up through here. And now I'm going to lay my ruler on. And I'm going to lay this ruler so that it goes all the way across the paper from one end to the other. I'm going to lay it on, and I may not hit every dot, and that's okay. But I'm going to do this. I'm going to start at the top end of this graph, and I'm going to draw a line that goes all the way across the entire paper. Look at this. I ain't scared. I wrote in the white stuff over here. Get some. I ain't worried about it. Look at this line. Did I miss one of them? Yeah, but that's okay. I drew a line all the way across this paper. And I ain't scared either. That's right. I'll do that kind of stuff because I'm crazy like that. All right. I'm actually going to make probably a part 2 for this video because I don't think I've got the courage to sit here and spend any more time on this video at this point. But anyway, the next part of this video will be finishing this graph, which we are thankfully almost done with this graph. The hard part of the graph is done. The last part is just calculating a slope. But anyway, thank you for your patience. Love you out there in Turd Ferguland, and have a pleasant third period. Bye.